When we think of space, we usually think of freezing temperatures. No air, no sun, no warmth. Just endless, cold darkness. But have you ever wondered, what is the coldest place in the entire universe? Where is it? And more importantly, why is it so cold? Surprisingly, it's not on Pluto, not in some faraway galaxy, and not even in deep, empty space. In fact, the coldest place we've ever found is right here in our own Milky Way galaxy. Even more shocking, humans actually helped make it colder than anything naturally occurring in space. Let's start by understanding how cold space really is. So how cold is space? In the vast emptiness between stars and galaxies, there's very little matter, just a few stray particles drifting alone. There's almost nothing to absorb or radiate heat. On average, the temperature of space is around minus 270.45 degrees Celsius, or 2.7 Kelvin. That's just a tiny bit above absolute zero, the coldest possible temperature, where all atomic motion theoretically stops. But even that empty space isn't completely empty. It contains the faint afterglow of the Big Bang, something called cosmic microwave background radiation. That radiation gently warms up even the loneliest corners of the universe to just above absolute zero. So, if that's the default temperature of space, is there anything colder than that? Yes. Let's talk about two places. One is naturally cold, and the other was created artificially. The Boomerang Nebula, the universe's natural icebox. The Boomerang Nebula holds the record for the coldest naturally occurring place we've ever found in the universe. It's located about 5,000 light-years away from Earth, in the constellation Centaurus. This nebula is a dying star, or rather, what's left of one. As it nears the end of its life, it's blowing out massive amounts of gas into space, forming a kind of cosmic bubble. And here's the amazing part. The gas is expanding so rapidly that it causes a dramatic drop in temperature. This effect is similar to how compressed air cools when it expands, like when you release air from a spray can and it feels cold. The result? A region of gas so cold that it measures only 1 Kelvin. That's minus 272.15 degrees Celsius, or just 1 degree above absolute zero. That's even colder than the background temperature of space itself. It's literally colder than the natural temperature of the universe. That's why scientists call it a cosmic refrigerator. So far, the Boomerang Nebula is the coldest naturally found place in the universe. But now comes the real twist. Scientists made something even colder on Earth. Believe it or not, the coldest known temperatures in the universe didn't happen in deep space, but in a lab here on planet Earth. At institutions like MIT and NASA, researchers have managed to cool atoms to below 1 nanokelvin. That's 0.0000001 Kelvin, a billionth of a degree above absolute zero. How is that even possible? They use a technique called laser cooling. By firing carefully tuned lasers at atoms, they can slow down their movement. And since heat is really just the motion of atoms, slowing them down makes them colder. Slower atoms equals colder temperatures. In 2018, NASA launched a special device called the Cold Atom Lab to the International Space Station. Its goal? To study ultra-cold quantum states of matter in zero gravity. There, they've created temperatures even colder than anything on Earth. Still not absolute zero, but as close as physics allows us to get. So technically, the coldest place in the known universe is wherever scientists are doing these experiments. But in terms of natural locations, the Boomerang Nebula still holds the crown. Why can't anything reach absolute zero? It's a fair question. If we're making things colder and colder, can't we just reach absolute zero? The answer is no, and it's not just because we haven't figured it out yet. According to the laws of physics, specifically, the third law of thermodynamics, absolute zero is impossible to reach. It would require removing all energy from an object, even the tiny vibrations of atoms. But even our best tools can't do that perfectly. We can get close, unimaginably close, but never all the way. Think of it like approaching the edge of a cliff. You can walk closer and closer, just millimeters away, but you can never quite step over without falling off. Absolute zero is the edge, and the laws of physics are the fence. Why does this matter? Knowing where the coldest places are might seem like a weird bit of trivia, but it tells us a lot about the universe. It helps us understand how matter behaves in extreme conditions, how stars die, and how quantum physics works. The Cold Atom Lab, for example, helps scientists study exotic states of matter, like Bose-Einstein condensates, where atoms behave more like waves than particles. Meanwhile, studying cold regions like the Boomerang Nebula gives us insight into the end-of-life stages of stars, the flow of gas in space, and even the formation of future stars and planets. In a way, the coldest places in the universe help us understand both the beginning and the end of everything. So next time someone says space is cold, you can tell them it's true. But some corners of space are colder than cold, and some labs on Earth have pushed the boundary even further. From dying stars 5,000 light years away to atoms dancing at near-zero temperatures just above our heads in space labs. The coldest places in the universe are reminders of how wild, extreme, and endlessly fascinating the cosmos can be.